So the next problem we're going to look at refers to the baseball 2018 data, which is information on the 30 Major League Baseball teams for the 2018 seasons. The number of games won, or wins, is going to be our dependent variable, and our independent variables are going to be the team batting average, or BA, the team earned run average, or ERA, number of home runs, HR, and whether the team plays in the American or National League. The first part of this question requires that we develop a correlation matrix of the variables for wins, ERA, BA, and HR, and then make some interpretations based on this information. So I have the data opened, and we actually get more than just the variables that were identified, but we specifically are interested in wins, ERA, BA, and HR. So I'm going to copy wins over to an empty sheet. And I'm going to do the same thing with ERA, BA, and HR. There's our earned runs. And here's our team batting average, or BA. And the home runs, or HR, I've got here. And now to create the correlation matrix, I'm going to go to the Data tab, Data Analysis. We're going to go to Correlation. And then the range of values that I want are from D31 back to A1. And I want to click Labels in the first row because the first row are the labels that we have. And if I want to produce this in the same sheet, I can click Output Range. And then I'll click this field and click any value in the spreadsheet that looks right. In this case, I want F1. And this is the correlation matrix for this set of data. So you want to make sure that it's organized in the same format as the table presented to you in your problem. So then you want to see which independent variables have strong or weak correlations with the dependent variable. And in my specific problem, it asks me what correlation exists between wins and the independent variable ERA. So I can go to ERA and see that the correlation is negative 0.88917 because that number is closer to -1. We know that it is a fairly strongly negative relationship between wins and ERA, or we would say that the two are not very tightly related, that they are quite different from each other. It's very far from 1. And then multicollinearity would be a scenario where we would be concerned that one of the independent variables may influence another one of the independent variables. And you may just want to do a quick lookup of Wikipedia or ask a friend if you're not too up on baseball statistics to know about the relationship between ERA, BA, and HR. And again, it's up to you to decide if that relationship between ERA and wins is something that is surprising or very interesting to you. The next part of the problem asks us to use a statistical package to determine the multiple regression equation of the variables that we used in the first part of the problem. And again, wins are our dependent variable, and then ERA, BA, and HR are all going to be our independent variables. So to do this, we want to use within data analysis, we want to go down and select regression, click OK. Our Y range, those are going to be our dependent variable, our wins are highlighted. And then with the input X range is going to be B, C, and D from rows 1 through 31. You can highlight them as a square. Again, in Excel, our independent variables always have to be side by side in the order we want to process them in. And in this case, each one of our variables is labeled, so I'm going to click Labels. And for later, we're going to want the residuals, so I'm going to click the residuals box now, just so we have it. And now I'm going to have it produce this in a new sheet, just to make it easier for us to take a look at the results. So I'm going to click OK. And these are the results we have of our model. So what we see is that our coefficient is equal to 77.15642. And then we subtract our coefficient for ERA, which is minus 19.9274. We add the coefficient for BA, which is 279.2906. And again, add the coefficient for HR, which is 0.091507. And then to see what the strength of this model is, we want to take a look at our value of R squared, which our value of R squared would be 0.871968, but because this is a multiple regression equation, we really want to look at this adjusted R squared value. Adjusted R squared takes into account the number of independent variables in your model, and that's important, especially when we're working with models that may have more than one independent variable in the model, or even you're comparing models that have multiple numbers of independent variables. So your value of R squared in a multiple regression model is going to be that adjusted R squared. And then the third question asks if the number of wins is affected by whether the team plays in the National or American League. And to do this, I would add a column to the data that you had worked with before. This is the data we used to create the correlation matrix. And in column E, I would create what is called a dummy variable, and I would assign values for 1 if they're in the National League and 0 if they're in the American League, and then use that dummy variable. The sign of that dummy variable and the significance of that dummy variable will give us a hint as to whether or not it's significant. So if you create that variable and you run a regression model again with that, you can see based on the significance of the variable, which we would look at by looking at the p-value to determine if whether the team plays in the National or the American League is significant, or if the league is significant at all. And if that p-value is less than 0.05, it's probably pretty significant. If that p-value is greater than 0.05, it's probably not going to be very significant at all. For the next part of the problem, we want to conduct a global test on the set of independent variables. So in this case, we want to look at the entire model, and this information is kept for us in the ANOVA table. So the first thing we need to do is state the decision rule at a 0.05 significance level. So here we need to find the minimum value we need to get for the F-test for it to be statistically significant. And to do this, I suggest using an F-test calculator that you might find online. So here's one that I like to use. You can see the link here. It's socialsciencestatistics.com/test/critical-values default.aspx. There's a ton of different ones available, and here we have the critical value of F. So our significance level is our degrees of freedom in the numerator and our degrees of freedom in the denominator. The degrees of freedom in the numerator, that's going to be the degrees of freedom in our first row, which is 3. And our denominator is going to be the remaining degrees of freedom, which in this case is 26. And if we summed up 3 and 26, we would get the total degrees of freedom, which in this case is 29. I'm going to click Calculate for F. The page is going to reload, but I'm going to scroll down, and it shows that the critical value for F is 2.975, or 2.98 if you have to round it. and we want to compute the value of the test statistic to see if it is significant versus this 0.05 level. So the critical value is the minimum value of f that we're looking for. And we see the value of f is actually computed for us. So you don't have to compute the value of f at all. You just need to find it in the ANOVA table. And then we need to decide whether or not we can make a decision to reject or accept our null hypothesis at a 0.05 significance level. We could do this by comparing the value of f that is related to our equation versus the critical value, or we can just go next door and take a look at the p-value. And whenever you see a number in Excel that ends with e and then minus a number, that means that you would move the decimal, in this case, over 12 points. So this number is really, really tiny. We get to, if we start at 0.0, we move over 11 places until we actually get to that 9. So that's really tiny. It's much smaller than 0.05. So that means that things are probably pretty significant, and when that's the case, we know that at least one of the variables is going to be pretty strongly related to, in this case, winning. The next part of the problem asks you to state the null alternative hypotheses to test the significance of each of the independent variables. And this is going to be a two-tailed test because you're looking at whether or not something is equal or unequal to something. You're not looking for greater than or less than. You're looking at equal versus unequal. And that's a really good rule of thumb for determining when something is a one or a two-tailed test. So the first thing we need to do is calculate that critical value for a 5% significance level. And again, we can go back and use a calculator like the one that I used for the f-test. So here, because it's the individual independent variable, we're going to be looking at a t-test. The significance level is 0.05, but because it's a two-tailed test, we actually have to divide that by 2, so it becomes 0.025. And our degrees of freedom is 29, because this is a one-sample test. Calculate for t, and it does the work, and that critical value that we're looking for if we're comparing t-values is going to be 2.045. However, we're lucky that we're given p-values for every single one of the independent variables in the model. So we actually know is that we have the p-values, and we know that if that p-value is smaller than 0.05, we're looking at a significant variable. So based on the results of these p-values, you should be able to determine independently if you need to reject or accept the null hypothesis. Generally, if our p-value is low, we're able to reject our null hypothesis and be excited that we found some level of significance. The remaining parts of the problem ask you to review the residuals and first determine if you feel the results are take a normal distribution. So to do that, you will put the residual values, so that those in column C here, and you'll create a histogram, and you'll select the histogram that most closely matches the histogram that you create with about 5. Well, I would aim for about 5 bins in your histogram, and then you also want to plot your predicted wins versus your residuals, and when you do that, you'll create a scatter plot of both of these values, and again, you'll choose the one in the assignment that best fits what your options are, and then you will interpret that result. And that's all there is to this problem, our baseball 2018 data problem. If you run into any issues, always go in and save your work and then let me know, and we can make sure that the computer is the one making the error and that it's not you. Hang in there, and before you know it, you'll be through this assignment.